Hello, welcome to this lesson in linear algebra. Actually, before we get to the material on multiplying a matrix by another matrix, I want to do a couple of quick problems just to solidify what we've learned so far, give you a little extra practice, and also working with the concept of an n-tuple. So what we're going to do is, let's say you have the first n-tuple will be 1, 0, and -3. Of course, now we've written it as parentheses with commas, but you now know that you can represent that as a column matrix or a row matrix. And the next n-tuple, we'll call it 2, 0, 4. And then the final n-tuple, we will have 4, 0, and 1. So we have three n-tuples. Each of them have three elements, so they're kind of called three tuples, really. I use the word n-tuple generally to mean listing of numbers. And what I'd like you to calculate, or I'd like us to calculate, is 3 times u1 minus 4 times u2 plus 3 times u3. We want to find out what that's equal to. And so what we do is we know that we can multiply a matrix or an n-tuple by a scalar, no problem. So we're doing that in three places, and then we're basically adding the results. So if we operate on u1 first, we multiply by 3, we know what we're going to get. 3 times 1 is 3, 3 times 0 is 0, 3 times -3 is -9. Notice I'm writing it as a column because typically the default way to write an n-tuple when you're writing it out, sometimes you see it in problems in terms of commas and parentheses, but when you're writing it out in terms of linear algebra, typically you'll write it as a column of numbers there. So what we've done is we've written it as a column and we've multiplied by 3. Now from that we'll subtract 4 times u2, and so let's write this guy. 4 times u2, 4 times 2 is 8, 4 times 0 is 0, 4 times 4 is 16, so that's what we'll have for the next guy. And then we'll add to that 3 times u3, so 3 times 4 is 12, 3 times 0 is 0, 3 times 1 is 3. So here we have three column vectors, or three n-tuples essentially, and we're doing addition and subtraction with them. And so we want to arrive at a final answer. Now notice that the dimensionality is perfectly fine to add or subtract these things because here we have the same rows and columns, same rows and columns, same rows and columns. So what we're going to do is operate on each respective element there. So 3 minus 8 is -5, and -5 plus 12 is giving you +7. So you see how we just go across doing the operation, we end up there with the final answer. 0 minus 0 plus 0 will give us 0. Now what we have here is you have to be careful. You have -9 minus 16. And so when you do these guys, -9 minus 16, for these guys here, you'll get -25. But then you're adding 3 to it. So if you go across, you'll get -22. So the column vector, or the n-tuple that you'll get, is 7, 0, -22 whenever you perform this guy. So this is a very common thing you might see on a test when you're asked to combine multiplication by a scalar with addition of n-tuples or of matrices. All right, now let's say we have, here we go, let's say we have matrix A is 1, -1, 2, 3, 1, 4. Matrix B is 2, 1, 1, 0, 3, 3. And then matrix C is 1, 0, 1, -1, 1, 2. All right, so we've defined three matrices. Notice they have the same dimensionality, same number of rows and columns. And what we want to find is we want to find 2 times A minus 3 times B plus 4 times C. So again, each matrix is multiplied by a number. That's totally fine, and we're essentially adding the results. Sometimes there's a subtraction if there's a negative number in there. But effectively, that's what we're doing. So let's go ahead and take care of that piece by piece. So 2 times matrix A is going to give us a new matrix. We'll just use the 2 multiplied by every element. 2 times 1 is 2. 2 times -1 is -2. And we'll have a 4 there, a 6 there, a 2 there, and an 8 there. I think you can agree we're multiplying every element by the number 2. All right. Then we have a minus sign here. And then we're going to do 3 times matrix B. So 3 times 2 is 6, 3 times 1 is 3, so we have 3, 0, 9, 9. That's basically multiplying each of those elements by the number 3, and then we have plus 4 times matrix C. So 4 times 1 is 4, and we'll have 0, 4, And then here we have negative 4, 4, and 8. So essentially what we have is that we multiply everything by the number 4. And so here we have a minus, here we have a plus. So what we're going to do is just go down the way. So we're going to say this is equal to 2 minus 6. 2 minus 6 is going to give us negative 4. Negative 4 plus 4 is going to give us 0. So that goes in the first position. Negative 2 minus 3 gives us negative 5, plus the 0 gives us negative 5. 4 minus 3 gives us 1, and 1 plus 4 is 5. 6 minus 0 gives us 6, plus a negative 4 gives us 2. 2 minus 9 gives us negative 7, plus 4 is negative 3. And then finally 8 minus 9 gives us negative 1, plus 8 is positive 7. So this is the answer. When we take the expression 2 times a minus 3 times b plus 4 times c, we get 0, negative 5, 5, 2, negative 3, 7. And that's how we basically arrive at that. So just a couple of quick practice drills or exercises to show you that when you multiply by a scalar, all you're doing is distributing that multiplication throughout the elements. And when you add or you subtract, as we've had some subtraction in here as well, basically all you're doing is going element by element in the corresponding places and either doing the addition or doing the subtraction. And now what I'd like you to do, once you understand this, is follow me on to the next lesson where we will talk about matrix multiplication by another matrix. So not multiplying by a scalar, but multiplying by another matrix.